Let's consider the situation when the use of nested families is most relevant. The first such case is when we want to use the same nested family in several parent ones. Let's say we have such an opening symbol for this door family and many other door families. We have created an opening symbol once, and we can load it into all these families. The second case is when, within the parent family, we need to control some kind of composite geometry. For example, we have loaded a door handle, or the same opening symbol inside of the door panel family, and mirrored these objects multiple times. Each of them is a composite one. The door handle consists of a sweep and a small extrusion form at the base. The opening symbol consists of a straight line and an arc. If we were to create such objects directly in the parent family, we would not be able to just reflect them. We would have to reflect each line, arc, or sweep shape, and then, individually, bind them to the new position and parameterize. Revit will not do this automatically for mirrored, copied, or moved objects. We have mirrored and moved nested families instances, but they work as solid objects. We didn't have to deal with snapping each line or shape within them separately after the mirroring operation. We just snapped the entire family instance to its position. The third case is when nested families need to be counted separately in the schedules. For example, in this way we can separately count door handles or any other objects. Moreover, the schedule will include only those objects that are visible in a specific family instance placed in the project. For example, we have 4 door handles, but when placing this instance in the project, we will only see 2 of them. This means 2 units will be counted in the schedules. We should note here that, by default, nested families are part of the parent family, and they don't get the schedules just like that. For a nested family to be counted separately from its parent, you need to change the custom parameter value inside of it. We will return to these settings at one of the next steps. The fourth situation we use nested families is when there is a certain component inside of the parent family, at the position of which we would like to place one or another object by choice. For example, our door family may have several different nested panels, and we can select one of them through the parameter. Let's consider such situation. Let's create another door panel that will be slightly different from the already created one. If we want to replace one nesting with another within the parent family, then each of these nested families must have the same set of parameters. I mean only those ones that are related to the parent family parameters. If one of these nested families is more complicated than the others, and we need more parameters there, then you will still have to create the same parameters in less complex families, even if it's not necessary for it. Otherwise, the program will give an error when replacing one nested component with another. Also, these nested families must have the same reference plane's position, through which the nested family instance is aligned in the parent. Also, these families must have the same categories. For the new door panel, we'll add glass. Move onto the elevation view and create a void extrusion form here to cut through the door panel. Let's draw a sketch. Snap sketch lines to the center reference plane through the equivalent dependency. Next, let's set the additional dimensions. To snap to the lower reference plane, you have to use the Tab key. Let's correct the dimensions values. There will be 150 millimeters. We will fix this value with the lock. And it will be 200 millimeters. Select the sketch line and try to change the dimension. The program gives an error. Can change dimension segment to this value. Obviously, this is because of the equivalent dependency. Let's press the Cancel button. To make it all work, you can remove the equivalent dependency. Then, set the size. And click on the Q icon again. Or you can set the dimension for half of the width instead this one. Both options will work. Exit Edit Mode and return to the floor plan. Our extrusion element should be exactly of the same thickness as the door panel. For convenience, I will disable the line thickness display mode. Using the void extrusion form grips, align its faces with those of the door panel. Don't forget to close the locks. Let's go to the 3D view. The hole was automatically cut from the door panel. Let's make sure of this by turning on the shaded visual style. Cutting with void forms is not always automatic, and in such cases you should use the cut command. Go back to the floor plan and create an extrusion that will be the glass of our door. I will snap the sketch lines to the reference plane through an equivalent dependency. Then I will form a dimension that will determine the thickness of the glass. Half of the thickness will be 5 millimeters. I will fix this dimension with the lock. Don't forget about these sketch lines. I already closed the locks here when I created the sketch. Complete the extrusion. I'll go to the elevation view. The glass height needs to be set. Let's do it. I will give this object the glass subcategory. And here we need to introduce a new parameter that will set the glass material. Let's create it. We have a situation when, in a given configuration of a family, the list of parameters differs from another nested family. Let's first save this family under a different name. I'll call it Glazed Door Panel. Let's close the extra views. To do this, go to the View tab and press the Close Inactive button. There will be one view from each open file. I will open the door panel family without glass. In this family, we don't have a parameter for the glass material. I have to create it. It should be named exactly the same as the parameter in another nested family, glass material. This will be an instance parameter, and its data type should be material. Click OK. Let's load this version of the family into the parent. Let's save the changes to the file and replace the existing version. Select the nested family instance and assign the parent family parameter to the glass material. Now let's go to the door panel family with glass and also load it into the parent one. We will not place the instance. In the project browser, we have two door panel families. Select the instance placed in model space. Nested family instances have a special parameter. It's in the Other group and is called Label. The same one is displayed on the line below the ribbon. The value None is specified for it. But we can create a parameter in the parent family and specify it as a value. Then, through this parameter, we can switch between nested families types. Let's do it. This one will have family type doors type of parameter. Door is a nested family category that was automatically recognized by Revit. Let's call this parameter door panel. Now, let's open Family Types window. Let's find the parameter we just created. Among its possible values, we have nested family types of the doors category, which we have in Family Library in this file. Since we didn't create types within nested families, a single type with the same name as the family itself was automatically generated. If there are several types within a nested family, each of them will be available in this list. Let's change the parameter value and press the Apply button. We will see that the door panel has been changed. Let's go to the 3D view. Since we set the extrusion element to the glass subcategory, it has transparency. This is a special property of this subcategory. Also, transparency can be set through materials. Let's save the family.